begin this lesson on area, we're going to be looking at summation formulas. So basically we'll be looking at things that have this sigma notation, where that sigma sign means we're going to add together. That bottom part, I equals 1, means we're going to start at the number 1. At the top of the notation is the 11, saying we're going to end at 11. So we're going to go from I equals 1 to 11, where the formula is 4. So what this really ends up doing is giving me 4 when I equals 1, plus 4 when I equals 2, plus 4 when I equals 3, and so on. I could write it out long way like that, but it'd be much easier if I had in my notes these 4 summation formulas that appear in the PowerPoint. So these 4 formulas tell me how to deal with different levels of I. Here there's no i's in the formula, it's just a constant 4. So it tells me when I'm integrating a constant c, I just do c times n. In this case, n is 11, so this is going to equal 4 times 11, which equals 44. I would have gotten the same thing if I wrote 4 plus 4 plus 4 plus 4 11 times. It would just take much longer. So hopefully I become familiar with these formulas and apply them to the different summations I'm asked to do. When I look at b, b goes from 1 to 20 of 7i. Here, my second summation formula tells me that I equals n times n plus 1 over 2. It doesn't say anything about how to deal with 7. But really what we're doing is we're going to take that 7 out front because it's a constant. And then we have a formula that we recognize. I equals 1 to n of I the summation. I equals 1 to n of I the summation. So 7 can stay here. This becomes n times n plus 1 over 2. So that becomes 20 times 20 plus 1 over 2. 7 stays. When I do 20 and 2 and I divide them, I can get rid of this and make it 10. So it becomes 10 times 21, which gives me 210. My final step is to multiply that by 7. 7 times 210 gives me 1470. For part C, here I have both things happening. I have a constant and I also have an I. So I'm going to split these into 2 different summations. The first summation is going to be from I equals 1 to 15 of I with a 3 out front. From that I'm going to subtract the summation from I equals 1 to 15 of 5. Here, this is going to become 3 times 15 times 15 plus 1 over 2. And from that, I'm going to subtract 5 times 15. When I go to reduce this, 15 plus 1 is 16. 16 divided by 2 gives me 8. So here I have 3 times 8 times 15 minus 5 times 15. So really, that's 24 times 15 minus 5 times 15, which gives me 19 times 15. If I put that in my calculator, 19 times 15 should give me 285. The final one in these summations asks me to do the summation from I equals 1 to 9 of I squared minus 5. Again, I'm going to split it up. Summation from I equals 1 to 9 of I squared minus the summation from I equals 1 to 9 of 5. For the I squared, I'm going to refer to my I squared formula. It tells me to do n times n plus 1 times 2n plus 1 all over 6. I'm going to subtract from that 5 times 9. So cleaning this up a little bit, on top I get 9 times 10 times 18 plus 1, still over 6. From that I'm subtracting 45. Here 6 does go into 90. 6 goes into 90 15 times. So this becomes 15 times 19 minus 45. We earlier did 15 times 19 just by coincidence. It gave me 285. If I subtract 45 from that, I get the correct final answer, 240. The key takeaway here is that you need these formulas in your notes, and you basically need to break down any of the summations into a constant times one of these formulas.